Welcome everyone. Today I'm going to talking about taking advantage of the runtime. I think I'm the one talk that didn't made it to have a description, so it is a brand new one. I gave a few runtime talks before, but I completely read it that one, and I think you find it very interesting. Before I start, I have to thank all the organizers. This is an awesome conference. I expected a lot, but my expectations were overthrown. I'm really having a great time here. I had seen great talks, and you've been a good audience. So thanks for that. So first, who am I? I'm Peter Steinberger. I'm StyPete on Twitter. My day-to-day job is a PDF framework for iOS. So a very interesting business because it's we sell to other businesses who make iOS apps, and it allows me to work a long time on very specific problems. I won't talk a lot about it, but you see a few screenshots because most stuff I open source or most stuff I do is somehow related to that one. And we're also hiring. If you're good enough. So the one problem I always have, like I'm a perfectionist, so I really take a long time to get the UI just right and make everything look perfect. But then there is UIKit, and sometimes there are just things in UIKit that you have to live with, but sometimes they're just too annoying. So one thing that I recently stumbled upon is a problem with UI print view controller in iOS 7. And it looks like this. So this is the menu, and you say you print, and then it says looking for printers, but it is awfully offset. I mean, I don't even talk about that crazy Xeon stuff. That is a simulator bug. That doesn't happen on the device, so it's not an issue. But simply that the label is offset drove me crazy. And I even understand why this happened. Apple probably designed this with an iPhone in mind, and back then it had the fixed size, so they probably messed the centering up. And my pop-up was just a little bit smaller because it adapts to the UI. And then it looks completely broken. And we actually got an email about this from some Japanese guy. And they, in the end, they don't care if it's Apple's bug or if it's our bug. They just want to have it fixed. So I fixed it. The corrected version looks like this. You go for printing, and it is centered. Perfect. So how would you go and approach such a problem? So because sometimes you can just subclass stuff from UIKit. But in that case, you only have UI print view controller. And that's like all you do. This is opaque thing and a few properties, and there's like not a lot of possibilities to fix things. So the first step you do is like, I'm pretty sure you all know Reveal already, so just peek into the view hierarchy and take a look how this thing actually works. And we see in Reveal that the label, let's zoom in a bit. The UI printer searching view has the height and the size of the whole controller. And it contains a label and an activity view, which the activity view is now hidden because it says no printer available. So apparently something in that UI printer searching view, something in the logic must be wrong, so it doesn't center right. So the next step you do is you go on GitHub, you check out the runtime headers from iOS. So the headers that were extracted at runtime, which show all methods and all instance variables, not just what Apple gives you, but for all classes. And you search for the printer searching view, and of course it's there. And we see that it is a very simple view. It has two instance variables. It has two methods that count, like search timeout and set searching, which probably sets the state. And that's it. And the name UI printer searching view is telling us that this is probably really only used in the printer view controller. So it's a good candidate to be fixed and monkey patched. So this is the code that would fix the problem. It's probably not the most elegant code. I use some helper methods to get the label and the activity indicator view. You could simply use KVC, but usually I use a helper that actually queries the view hierarchy and pulls out the first label or the first activity indicator it finds. That way, it is a little bit more future-proof. If Apple changes something in the future, stuff won't break. If you use KVC and the instance variable is no longer there, then you probably get an exception, which is really not what we want. And then we use some basic centering code and simply change the origin of the two frames, and that's it. Now the interesting challenge is how can we put this back into UIKit, and also how can we put this back in a way that Apple doesn't mind. So I use a few tricks there. First, I really like packing things into C functions, because you could also pack this into a class, but it's really like a contained fix that you can either enable or disable if you add or remove the function. So we use a small trick which is called attribute constructor, which actually makes this function into a constructor, a global one, which will run very early in the game. Now, you really shouldn't overdo using attribute constructor, because it will prolong the startup time of your app. If you do only some minor things like that, it won't be a problem. But if you have like 100 places where you use attribute constructor, it can be quite a problem. Somebody told me at Apple that they are not allowed internally to use attribute constructor, because it will simply slow down if you link with all kind of frameworks. Every framework would do a few attributes. That would be trouble. But for our own app, it is okay. Next up, we need to actually get the class, the UI printer searching view, because there is no header for that. We use ns-class from string, get the class, then we check if it actually exists, because this could run on iOS 8 and maybe Apple changed it or fixed it. And then if the class is no longer there, we don't need to do anything, when we just hope it's fixed then. And then we just create a new selector. We swizzle layout subviews, replace it with our own method. We call the original one, because we don't know what else they do, so we always have to call basically super on it. And then we add our custom layouting code that you already seen. And at the bottom, there's a method which is named replace method with block, which is just a helper that basically swizzles the two. Now, the whole thing looks a little bit different. There are a few other things that I had to add to make it future-proof, make it safe. Be very careful about it, add a try-catch. But in the end, what I explained is the fix, and the other things are just a little bit of markup to make sure that nothing breaks, even if things would go wrong. And that's it. That's how you would fix UI printer view controller in one C function. So I actually shipped this, so it's not something that is like a theoretical thing. This is in the Dropbox app, for example. The next thing is UI text view in iOS 7. Who had problems with UI text view in iOS 7? Yeah, I'm surprised I don't see more hands. You need to upgrade. So this gave me a lot of trouble. And not only me, but a lot of people. And in many ways, what Apple achieved is like very amazing. They replaced so many things in iOS 7, and they changed UI text view from being backed by basically WebKit to be backed by core text and TextKit. So if you added an attributed string in a text view on iOS 6, internally it would create HTML code, and that HTML code would then be sent to some internal UI web view, not a web view, but like a similar class that would actually render the text. So something that is actually quite wasteful and had its own problems. Text rendering was different than the text rendering of core text, because they too shared no code at all. So what Apple did is something that was actually expected, that they moved over the TextKit part and unified the whole code. But in many ways, UI text view now is pretty much a 1.0. It's like a completely new start. And on iOS 7, you actually have a underscore UI compatibility text view, which is a whole different class. It just looks the same, but that's the iOS 6 version. You get that when you compile with SDK 6, and with SDK 7, you get a whole new class. So it's not completely unexpected that there are problems. And this is what happened when I first started updating to iOS 7. And I type in text, and as you type, suddenly you don't want to see the text. It's behind the keyboard. So when you scroll up, you still see it, but then it disappears again. And then when you change the text caret, it doesn't scroll. The text caret is gone. If you use a hardware keyboard, you could do that. If you click into it, the caret is visible for a short time and then disappears again because the keyboard comes up. So it's like it's really, in a way, kind of broken. And in a way, I also pushed it a little bit because I used a new interactive dismiss mode from the keyboard. And to make this really good, you need to set the content inset. You don't change the frame, but you change the content inset. If you would change the frame and you drag down, then you don't see the text. And as you finish dragging down, then the text would magically appear. But it's not a nice experience. So using content inset is the correct way. But that one is actually, unfortunately, a little bit broken by Apple. So I sat down and worked around this. And I'm not going to talk about the specifics how I worked around. We now see that it is working as expected. We see the caret all the time. When we move the caret with the keyboard, it scrolls. When we pass text, it will behave correctly. So this is, I mean, the fix is really like rather mundane. It's like adding delays, manually calculating the rect, and then figuring out if the caret is visible. If not, then you manually scroll. You basically do what Apple should do. It's not something very exciting. It's rather something that is annoying me very much. And the actual problem is, how do you best encapsulate that fix? Because I first started, of course, with that view controller. And I had some delegates already before. I needed it for other things, and I just added a check. If it's a \n, then maybe manually scroll. And that worked. And then I realized that actually I had 3 places where I needed this. So I really don't like to copy code. So what I first did is, first was the custom code in the view controller. Then I made a category. And each place called a category, and the category did all its custom calculation thing and making sure you're scrolling and handling all the dirty detail inside that category. And in the beginning, I only needed 1 delegate method, so it was okay. It's still 1 manual call, but it's kind of like a lot more dry. And then I played more with it, and I figured out, oh, I need this second delegate as well. What if you pass text? When you pass text, the delegate I used wasn't called, so I need a different one. And then when you have a hardware keyboard and change the caret, there is another delegate as well. So I was at 3 delegates. And 3 delegates in 3 methods. There are 9 functions that I had to make sure they're always correct and always call to the correct category functions. So that wasn't a good solution. So I ended up subclassing it, which had its own problems because I need the delegate of the UI text view. And maybe other people need a delegate as well, so it should be kind of like transparent in masking what it's doing. So if we look at the UI text view delegate, there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9 methods. And those 3 are the ones I need. And some people on Twitter suggested that I could simply use notifications, right? That's why notifications are also there. You don't need to mess up with the delegates. But they're only a part of the game. Like for some, I could replace them with notification. For some others, there is no real replacement. How would you replace a should change text in range, which returns a Boolean with notification? It just doesn't work. So notifications were out of the game. We had to use the delegates. So in the end, I created my subclass, PS_PDF text view. I know it's a very long prefix. And in that subclass, I save the real delegate that is set from the outside, because I'm also inside my own delegate. And then I override set delegate. And first, I had added a check if we really require those crazy hacks, because on iOS 6, this simply returns no, and it behaves as it would on iOS 6, and it's correct. We only need this on iOS 7. And on iOS 7, I set the delegate from super, from Apple's class, to myself, to my subclass. And my subclass now saves the real delegate that's going externally. And then for each delegate I need to do those 3 things. First, get the delegate, make it strong. Because we are good citizens, we enable all warnings in Xcode, and one of the warnings is 1 on multiple usage of weak. So we need to make the delegate strong before we can use it. Then we call response to selector, and we actually take a shortcut and use the _ command, which is the selector of the current method, so we don't have to type everything twice. And if it responds to the selector, we call text_change selection, basically the original implementation, and afterwards we call our custom fixing code. So that works, but the problem is we have 9 delegate methods. You need to do this 9 times. And this is repetitive code, and it's also very prone to failure. It's very easy to make a mistake. It's easy to forget something. And if you look closely again at the delegate, those 2 methods, they have only been added in iOS 7. And since I already told you that you're text views, so very much a 1.0, it wouldn't surprise me at all if we get another delegate in iOS 8, and then my code would no longer work. And in iOS 8, I might have forgotten what crazy things I did in there and didn't write the forwarder, and then like the delegate's just not called, and it's like a bug waiting to happen. So manually forwarding is really not what we want. We want to use, to make this automatic, we want to use message forwarding. And it's actually a lot easier than you think. Message forwarding has 3 steps. First, we lie. There is response to selector on NS object, and we simply override that and call super. And if this object doesn't implement this method, we call the real delegate and ask the real delegate, hey, can you handle that method? And if that returns yes, then we also say, yes, we respond to that method. And then whoever calls us will send the message to us. And then the runtime will say, hey, I don't even have a message for that. Why are you calling me? And it will try to create an NS invocation. And NS invocation is basically a message frozen in time. And before it can create the invocation, it needs the method signature. In the method signature, there is some stuff in there like, what am I actually returning and what are the actual parameters? Because the selector is not, doesn't have enough information. You need the exact type to create an invocation. So we do the same game again. We call super. If that returns nil, we try with the real delegate. You see my love for the ternary operator to make it very short. So it either returns super or it returns the second part. And then we override forward invocation. And there again, the same game. We get the delegate, the real one. We ask it, do you respond to that selector? And then if it does, we invoke the delegate. And done. And it was working beautiful in iOS 7, and then I tried it on iOS 6. And there was one small part missing. Yeah, the text caret is gone. I only noticed because I only noticed at testing, so this was not on the same hour. It's like a little bit later. It's like, oh, I forgot something. So I stepped into the invoke method and saw that there was one method sent which I didn't expect, which the runtime was asking for an insertion point color. And of course, I wasn't thinking about fixing it. I was thinking about abusing it. So you might think the easy way is, oh, let's create a method then. Let's create insertion point color, return red, and we have a red cursor. Awesome. On iOS 6. No, I did it the hard way. I implemented else. I checked if the invocation is that one invocation that is evil, and then set manually the caret color as a return value, and I got the green blinking caret on iOS 6. Of course, this is not something you would ship. It's more something I did for fun. The actual way how to fix it is that we simply forgot calling super. We are good. We want to be good citizens. So super is good here. The default of forward invocation on NS object will simply say unimplemented method, I'll crash. But maybe some other people did some smart stuff as well, which probably is the case here. So we always need to call super in that case, else we might break some code, which we don't know about. So in that case, we broke iOS 6. So that was the second part. Now I come to the real awesome part, actually, which I also hacked yesterday in the hackathon. Inspecting third-party apps using Reveal. So who of you are web developers? OK, so web developers have the web inspector. And that's always something that I'm very jealous about. You can just open the inspector and see how things are built. Are they using tables? Are they using divs, spans, or whatever crazy things? How does the CSS look? How is the website built? It's an open book. Like each website, you can just take out and read. Or you can also read all the code, which is even more awesome. But even like looking how it's built is so interesting. Wouldn't it be awesome if we could that on iOS? And by default, you can't. But there are some tricks to make this possible. For example, this is the App Store exploded in Reveal. You see like this crazy grid on the top and some fake shadows, and you see that it's all native. And there are also some crazy names for the various stuff they're using and the class names. Even just seeing the view structure is so interesting, and you can learn a lot for your own apps. Of course, it's not easy. You need to have a spare iPad, preferably one that is not ARM64, but although it works now on ARM64 as well. And you have to jailbreak it, which I'm not a big fan of jailbreaking, because usually it's in combination with piracy, and I really don't like piracy. But you can also jailbreak just to learn and to get a deeper knowledge of the platform. And if you use it that way, it is really interesting, and it allows you to do things that you normally can't do. I blogged about this, and the blog post is not up to date. I need to add a few new things, but it will get you 80% that way. So once we have jailbreaked our iPad, we need to install OpenSSA and Cydia. OpenSSA is very standard, and Cydia substrate, previously it was called mobile substrate, is pretty awesome. It actually has only one public method, but it allows to override any function or any method, pretty much like we swizzled before in the print view controller, but on an app global level and on any app that I want. It also allows that I simply load my own code into other apps, which is amazing because my code can change the other apps or like interact with them. And you can create really weird stuff with it. But what we want to do is we want to use this loading facility to load libreveal into the other apps. So the first step is that we actually have to get reveal onto the device. So we use SSA and copy libreveal dynamic library into system library frameworks of our jailbroken iPad. And the next step is that we create a filter. And those are mobile substrate filters. They have this one reason, so mobile substrate knows in what app it should include this dynamic library and in what app it shouldn't. When I first tried this, it was possible to use a star, and it would include it in everything. But there was an update lately that somehow broke this, so you really should only use it as explicit app IDs. Don't put a star in there, or your iPad might not start up again. And I also tried Spark Inspector. Some people reported good results with Spark Inspector, but my iPad didn't boot up anymore when I tried that. Luckily, there's safe mode when you hold up the volume up button. There are a few things in mobile substrate which are really smart, so it was not a big problem, but I ended up just reusing Reveal. So this is how Keynote looks in Reveal. I was specifically interested in Keynote because in many ways my framework does a lot of the same things, especially with the canvas handling, having selections of objects that you can resize. I was very curious how Apple solved the problem because it took a very long time and I'm not entirely happy with my solution. So I looked at the view hierarchy and I've seen the TSD canvas view. It's like, yes, that's what I'm interested in. And that's the end of the story. It's like, where are all the views? Like, what is happening? So like one theory was either Apple is using OpenGL. Maybe they do everything in some crazy way, but then again, why would they? It's like it's perfect for UIKit. The other reason is Reveal doesn't show layers, which is a big downside. Usually app developers don't do such a lot with layers. You get implicit layers with your views, and that's usually good enough. But maybe Apple was smart there and did more with layers than we see. So anyway, that didn't stop me. We need to go deeper. We need to figure out what's going on there. So we have LLDB, and LLDB is really awesome. Wouldn't it be cool if we could attach LLDB to the other app? That's what I did. It's some really wicked stuff to get this working. So you need a binary which is called build server, which is hidden in some really long parse in a disk image on your computer, on your Mac. You need to copy it somewhere else. Then you need to write an entitlements file, which has some specific keys with Springboard debug applications, run on-site code. Really, like, there's no way you could figure it out without other people having already worked on that and written examples. And you need to sign that binary with those entitlements. So to have it code signed and also changed, and then you copy that changed binary again via SSH on your Mac, on your iPad. And there you first start Keynote, and then you start the debug server. And there the star means like it accepts any IP on port 1234. And what it will then say is, oh yeah, I'm attached to Keynote. I'm that version. I did this on ARM64. And now it's listening. And Keynote stopped because it's now in waiting mode. And then you go on your Mac and you type LLDB. And then you type platform select remote iOS. And you get this big list, which I didn't print out, which is all the platforms that the remote iOS protocol supports. Then you can say process connect, and you give them the IP of your iPad and the port we just set. And then it takes like a few seconds until LLDB transfers all the symbols to your Mac. And then it shows you the stack trace of the app it's currently in, and then you have LLDB. And you have this magical, you can do anything now. It's like, and of course the iPad then just says, waiting for debugger instructions. And yeah, LLDB, so before we continue, like a small crash course, what can LLDB do? Every one of you is using LLDB, it's in Xcode. Previously there was GDB, but LLDB is now really better, and they even removed GDB. So the easiest thing is print object, PO. You can print any class. Here I print the US screen main screen because it's a nice singleton. You can print variables of that class. Here I'm using value for key to get the scale, and value for key is using KVC, so it packs the float into an NS number and returns the NS number, and then it simply returns 2 as an object. I could also call scale directly, but then LLDB is not that powerful again. It doesn't know what it returns. So if you just type P, US screen main screen scale, it says, oh, what do you expect? I don't know. And you have to type CG float. If you just type float and you're an ARM64 machine, it will simply return garbage, because on ARM64, we have double. So type CG float and you're correct, and then you get 2 again. So I often use the value for key stuff because it's simply, I need sync less. You can run expressions. I could now run Keynote, and I could say, your application, shared application, set badge number to 999. And then the badge number would be 999. It probably would never be reset because Keynote doesn't have such a feature. Not a very useful case, but you can do things like change colors. You can change basically anything in the running application. It is a little tedious to write sometimes, but it is very interesting to see how it reacts. One thing that is not very well known and is very useful if you use KVO, I don't say that KVO is bad, it's just that you should know what you're doing. If you use KVO, then you should also use appropriate context. Usually your context is like a const char, something defined somewhere statically. And then if your observe function gets more tricky, sometimes you would love to see what context am I. And Xcode will only show an address because it doesn't know. It doesn't have the name of that symbol. It really only has the address. There is no way to figure that out at runtime. But LLDB can do that. If you say image lookup.h /h context, it will look up where that symbol came from, where that address came from, and will print the symbol name if it's a valid symbol. So in that case, it really knows that it is a PS/PDF annotation toolbar parent bar context. So that is sometimes really, really useful if you have a more complex operation on KVO. And of course, LLDB can do backtraces. And I work a lot with customers. And they always send me screenshots of the sidebar of Xcode. And a lot of the time, they don't know that at the bottom, you can control how much is shown. And then they send me the stack trace, and 50% is missing, often the important parts. And then I always have to explain them. I just type bt all or bt. bt is backtrace, will give you the current thread, and bt all will give you all threads. And will simply print the state of all threads in a nice way that you can copy into an email or a gist, and which I can read nicely. not images that maybe have to be stick together because they are too long. So BTO is very, very good to know. You can also define breakpoints with LLDB. You don't need to use Xcode, although Xcode UI is very handy often. But you can also do this manually. You can say breakpoint set minus n. N is usually a function. S is a selector. Or you can also use n and be more explicit about it. Here we want to have the selection, but we also say it only has to be in that class. And then LLDB will tell you if it found something or not. This is something that the breakpoint view in Xcode will not tell you. If you have a typo, it will accept and it will just don't break. If you set the breakpoint with LLDB, it will tell you if it has found something or not. And then there is also the basics like list or delete, because the breakpoints you manually set won't show up in Xcode and vice versa. So finally, we did a small backtrace to LLDB. Let's go back to Keynote. And the first thing, like I was waiting for that. It took like a few days to figure everything out, and then finally I had this LLDB waiting for me. And the first thing I typed in there is print object, UI window, key window, recursive description. And key window is actually private API, but we don't care because we already jailbroke and it's debugging. It's like, but it's like the shortest case for description, and recursive description will print the whole object. So suddenly the world looked very different again. We got this, like a whole lot of views, a whole lot of layers. It's like quite a complex hierarchy. It's like 50% was missing in reveal. It's like a lot more information. Again, this is what reveal looked like. And I was especially interested in the canvas view. So this is the canvas view in reality. So we see that Apple really used the canvas layer and built all that functionality with only layers. This is very interesting, and I'm curious if they maybe shared some code with the Mac, because it's probably easier if you just do it with layers than with UI view and NS view. But they use something like no default implicit action layer and tiled layers and shape layers and highlight layers. And just from looking at that, you can already figure out how they probably do object selection. So this is very, in a word, revealing, without reveal. And then the game continues. You can use LLDB and peek around, which is a little bit tedious again, because you have to type a lot, and there is no syntax completion. But I finally managed to be able to get to the canvas view and the canvas layer. And then you can use the runtime to see what variables are in that object, which is very tedious again, because you have to use copy eval list and then get name, and it's like that much to write. And if you make one typo again, it will break. But again, if it will break, it just breaks with execution. You can just try again. LLDB is very forgiving in that part. And then we figure out that there are two evers, probably. One is mcontroller and one is a layer host. And then again, we can use value for key to get to those objects and really like sneak our way around and slowly figure out how the app was built, what are controllers, what are the subclasses of that, what methods are implemented. But it's really like, as you've seen, it's tedious. There's something called Cycrypt, which is very well known in the jailbreak community. I'm not big in the jailbreak community at all. That's basically my first attempt to really jailbreak and learn from that. And they have a bridge which translates JavaScript to Objective-C, which is very handy to script access. And I would have loved to use that, but it's not updated for ARM64. So I just picked that from the internet. It's not working yet on modern devices. There are also some other interesting developments, like I've seen RubyMotion trying to do the same, to inject code, which is even something that I'm looking forward more, because I would love to script a run in Ruby, even just for debugging and figuring out how things work. So I'm definitely sure that there will be more in the future of those things. But again, we are at square root one. We wanna have it make it simpler to inject code, to inspect code, and for that we have to inject code again. because we can write our own libraries that make it simpler to then figure out how this other stuff is built. So I was making my way on the progress to building my own dynamic library. But the problem is, if you open Xcode and say iOS frameworks, the only option is building a static library. And there are some guides on the internet how to build a dynamic library with Xcode. I spent like 5 hours on this. I patched all kind of files, did really creepy things, but in the end, it didn't really work. It doesn't really work anyway with Xcode 5. It's not something that Apple does. It's something that Apple don't want you to do. It's not a good idea. But we just can do it ourselves. We have Clang. So we can just take our own source file and compile it. We cross-compile it on the Mac for, in that case, ARM64. We tell Clang, make a dynamic library. We probably also want to link with Foundation or whatever other frameworks that are required. And then we just say, make a dlib. And then it takes the .env file and builds what we want. And the contents of that is rather simple. It's just like getting all the evals, printing them, making them pretty, and making like a nice output. So not going into that one. And it's also very similar to Reveal. Just again, copy it into the folder, create a filter, add the same app ID. Then you have to restart Springboard or reset your device or something like that, and then start again, do all the connection process again, and then when you're back at LLDB, you can type image list and get a huge list of all the dynamic libraries that are loaded, and there are a lot more than you might think. And you just search for your library. If you did everything correct, it will turn up there. It took me a few attempts, but finally my library was showing up there, and libreveal was also there. So in the end, I could use the same stuff again I used before, but use my own categories and as object to get a nice printout how the classes actually look. So I don't have to type everything manually. I just say class info, and it will print out all the instance variables. And I don't scroll there, but it's really long. Or I have a second one that says dump, which actually also gives me the contents of each instance variable. Now there were some problems with that, but it is possible to write something that will give you all instance variables of the current class. And making that dynamic library took me crazy long, like really long. That was quite tedious. And then I was like quite desperate for a long time because there were some problems hitting. And then somebody wrote me on Twitter that in iOS 7 there are actually new methods that do exactly the same. So there is a new one which is called IWA description. There is one that says method description, and one that is short method description. And they are a lot better than what I wrote. So even if you're inspecting your own app and you're in the debugger and you're noticing about some state and the Xcode panel is not really working for you or you're somewhere else, you can just type _IWA description and you get a really nice overview. You should probably never use method description because it will show every method back down to n as object, which is far too much. You always want to use short method description. In the end, I used a combination of both to figure a little bit out what Apple did. And this is only just a start. Like the next step would be using GDB on the device, and then you could dump the memory and get a unsigned copy of the app, which you could then run class dump on. And then you would see the whole class hierarchy as it is offline and the class hierarchy as it is at runtime. And you could really find your way and really reverse engineer if you're that curious about how things are done. Usually I'm quite okay with just seeing the view hierarchy and I got some new ideas. But if you're like curious about some competitor, there is nothing stopping you. There's nothing stopping you from then using the dumped stuff and starting either or Hopper and like basically reading the source code. Yeah, and I ended up like looking at a lot of apps, just seeing how they're done. Like the Chrome app is a full screen UI web view. They just changed the content inset and added the stuff on top. The controls actually above the UI web view. Or I was a big fan of the old Twitter app on iPad, like the one that has the slides, which Lauren made, and I looked if there are still some parts of Lauren in there, and there were. So if you open up the Twitter app, you still see something that starts with AB, some other stuff that starts with T1, which made me a bit nostalgic. And I even opened up Photoshop Express, which I expected to be like some weird Flash Flex-based stuff. And it was a fully native app, like with perfectly named class names, very well structured. So they apparently have a lot of great guys there. I was impressed. It's actually my cat. Yeah, there are some more screenshots on my website. It's too much for today, but it's really something that if you think a little bit outside of the box, you can learn a lot by peeking into other stuff. Thanks for listening. Oh, and I forgot, if anyone wants CocoaPod stickers, Orta has a lot of them. He's at about 2,000, so. Oh, and questions.
I really enjoyed your talk. Nice hacks. And the question is, what keeps you from sleeping at night? Actually, I'm thinking about, you've changed something in UIKit, have done some method swizzling, things like that. And first of all, what are you afraid of in the future version? Is there anything that you're afraid of that's going to change in the internals of the things that you've changed? And the second thing is, what, aside from the catch and what you've shown, are you doing or thinking about trying to counteract the things that might change and break your code?
Oh yeah, that's always a risk. I try to be really careful when I create those hacks. That's why I showed you the last slide, which was like that much longer, like packing everything in a try catch, making sure both views are found, and only then modifying anything. Sometimes I make a check that I'm being pessimistic about something and only allow known operating systems, so only iOS 7 or 7.1. But on iOS 8 it would be disabled, which might be a small regression, like something is offset or some animation is quirky, but it's like less risk than not knowing what Apple might change. But the more you know what you're doing, the more careful you can be about applying those hacks. And for example, the offset change, if Apple would fix that, my code would simply do nothing. It would calculate the same offset, and then it will simply not change. So that's the best case. The worst case is that they change the class, and then my fix wouldn't even be applied, because I look at runtime for the class. But there are always problems. Like, there was one big problem where I needed a way to detect at runtime the SDK you were being linked to. But since I provide a framework, I don't know that at link time. I really need to know that at runtime. So I peeked a little bit around, and in the iOS 7 legacy mode, the tint color is nil, because there is no concept of a global tint color. And on iOS 7 in the flat mode, the tint color is the color you set to, or white. And I used that as a way to detect at runtime if we are in the old or the new mode. And on iOS 7.1, it always returns white. So that was very unexpected, because there is no reason Apple should ever change that. And I really wasn't thinking that it could happen, but it happens to the best of us. And if people don't upgrade, there were some versions that they won't crash, but they will look pretty weird, because they try to look like iOS 6 on iOS 7. But it's not something that would crash. It's more like a visual annoyance, which cranks me out a lot. So, and we solved this gracefully in the new version. We actually disassembled how Apple is doing it, using a weird NS version of LinkTime library, which I've never seen before, and Cedric Lucy helped a little bit. And now the new way can't break, because Apple would have to change their own way. But there are always risks. That's the thing, how far you want to go. It's like, if you can live with those problems, then it's okay as well. But sometimes they just annoy me too much.
Thank you.
Any other questions?
Okay. Oh, there's one.
Can you show the slide where you were fixing the print view controller?
Oh.
The fixed one.
That was very at the beginning. I hope Kino doesn't crash. It happened a few times. That was the text view. You mean the visual, not the code, but the visuals?
Second.
Wait, that should be that video. Oh yeah, you're talking about that weird glitch.
Oh, that's okay.
It still looks a little bit offset because of the title, but if you use like a tool,
that's not my complaint.
Okay.
When I first saw this picture on your Twitter or blog, I didn't read the text. And I tried to figure out what was wrong with the picture, and my first impression was that the pop-over arrow is.
Don't talk about the pop-over error. You know, I'm that close. I'm that close in investing time, but I thought like I almost made peace with it.
OCD kicked.
You're gonna read my blog post tomorrow. Okay. Any other complaints about arrows?
No. Can you please show a slide with forward invocation code?
With the invocation.
It's near.
This was. Wait. This was the text view. The animations. Wait a bit. Yeah, that's a mistake when you put in too many animations. That was the broken one. Do you want to see the fixed one?
Previous was forward invocation. Any reason to use forward invocation instead of forwarding target for selector? Because
yeah, I actually tried with that, and for some reason it made a lot of problems with text view. I use the faster method forwarding for a class that handles proxies and like delegates, but on that example it somehow didn't work, and I settled with that one because the invocations are really not called 1,000 times per minute. It really shouldn't matter at all. But yeah, the new variant should be better, but somehow maybe you can submit a pull request. It's that the fix is on GitHub, so I would welcome that.
Okay, I'll check.
Okay. Thanks for listening.